Well, welcome everyone on this sunny afternoon in February for the CCSE workshop on data analysis in network analysis. We wanted to put these sessions together to give people an idea of the kind of techniques that people were using in analyzing the video library or potentially could use. So this today will be on network analysis with Sorin Matei, is a professor of communication and associate dean of research and graduate education in our College of Liberal Arts and one of our own faculty here at Purdue in the Lamb School of Communication. He's no stranger to big data. He knew Wikipedia when nobody was paying much attention to who was editing and how much data there were there, and did some amazing first research using that. So it's very involved in research initiatives, grant writing, grant making, data analysis, and he's going to talk to us today about network analysis. So, Sorin, take it away.
Thank you, sir. Thank you,
Everybody should stay muted, and if you have questions, put them in the chat to everyone, and Kai will read them at the end, and we'll go through questions that way. Thank you.
Yeah, thank you, Robert. Thank you all for making time to join us for this.
Sorin, you got muted a minute.
Did you hear the thank you part, or should I start again? Yeah, so thank you again for joining us today. Robert invited me to talk with you about network analysis, both in general and as applied to the C-SPAN archive. The presentation that I will give today comes out of a demo project, pilot project that I conducted a number of years ago, which was then published as a paper as a chapter 1 of the C-SPAN conferences book. So if you are interested, there's a paper to go with it. Let me share the screen with you really quick here. So what I would like to talk with you about is let me be a little bit more specific than this long title: Enhancing the C-SPAN Archive with Communicative Metadata Practice Capital Proposal. What I'd like to talk with you about today is the possibilities offered by the C-SPAN archives to create networks of interaction and study networks of interactions between the speakers captured by the C-SPAN archive. And this can lead to two different things. On the one hand, this can be used for research and for revealing some important features of the public conversations, but it can also turn into new features for the archive itself. Okay, so my idea starts from a simple proposition, which is that the C-SPAN archive is a big data repository. It's social and political big data. And this is so because what the C-SPAN archive captures are not just moving images or the words uttered by the people captured in these movies, but most importantly, interactions between these individuals. And I'm talking here about who says what to whom, right? So every single video on the C-SPAN archive site contains a chain of interactions. Somebody says something to somebody. Now, somebody in the room or somebody outside the room, but we can only focus on conversations between the people in the same room or in the same space or in the same public debate that might take turns in that conversation, especially if it's a conversation that takes place over several iterations or sessions, such as in a political debate that repeats itself, over many, many days. So if we imagine the C-SPAN archive as a chain of interactions, as a chain of who says what to whom, right? Each time somebody says something to somebody, a link is created, right? There's a link of communication. There's an interaction between these individuals. Now, it is not necessary for the people to speak to each other directly in conversation manner, but to address each other, right? If I say, Robert is a great guy, and he knows a lot about C-SPAN archive and all that. I was talking to you, but I was referring to him. So I have an interaction to him, and now, as a consequence of me saying something to him, he might say something about me or to me, right, or not. Or next day, he can talk about this talk and mention me, and by doing that, he has created a broader conversation interaction between us. And this is how I think about the C-SPAN videos and archive, as a network of interactions based on referral, rather than just based on very direct communication. Now, you can make these conversations, interactions, and communication networks broader or narrower as you need, but again, I take this very broad understanding. Now, I just mentioned the word network, right? Because I imagine the C-SPAN archives not only a collection of strings, right? Or somebody says something to somebody who says something to somebody. I imagine it as a collection of strings that intersect with each other. And as they intersect, they create networks, right? And we create basically a social network of debate by thinking about the problem this way. So let's just imagine this hypothetical situation. That could be a C-SPAN hearing, or it could be anything, right? Where we have these actors, Jim, Dan, Rachel, Jim, Rachel, Ann, Stephanie, Alan, Stephanie, Alan. You can call them Congress people, experts, whatever you want, right? So just imagine that in this video, Jim says something about Dan, and Dan says something about Rachel, and Rachel says something about Jim, and Rachel about Ann, and so on and so forth. Although this appears to be a linear interaction, right, from person to person, what you in effect have is a network of interaction, right? Where, Jim said something to Dan, who says something to Rachel, who says something to Jim. But Rachel also communicated to Anne, who communicates to Stephanie, who communicates to Ellen, who speaks back to Stephanie. So what we have here is not only a network, but we have a network with two cliques, right? We have the Jim, Dan, Rachel, and Stephanie, Ellen clique. Now, and then there's Anne here in the middle, whom I did not put in any clique because she is a bridge, a connector, right? So we have a very interesting network here with two cliques, a connector, and actually an individual that has a lot of connections, more connections than anyone else, who is Rachel, right? So when you get the network, when you create a network, right, from communicative metadata, that's what I call these interactions, communicative metadata. This is data about the individuals, right? When you create the network, you can evaluate each member of the network for their role, importance, and impact. And these are three different things. The role, can be one, the level of importance could be another one, and impact could be another one, right? And after you do this, you can rank people, and you can tell who plays what role and who is important and who is the most consequential, right? And then you can use this to visualize this information on some sort of interface. And this is what I propose for analyzing C-SPAN interactions, that you can use network analysis to define roles or levels of importance, impact, but then you can build that into the interface to see or sort people by these things. There are two ways to do this. One is to just look at who said what about whom, but you can also use other types of criteria for connecting people, such as keywords. If two people talk about the same topic, even if they don't address each other, you can still connect them, right? You can also use time. If somebody says something about something really close in time to somebody, again, even if they don't talk about each other or about the same topic, but they talk in the same time space, that you can connect them and all that. But these are details. The really fun part starts when you start thinking about measuring the presence in these networks and thinking about the things that are not immediately apparent, right? When you start using the network to tease out issues or characteristics, features that are not immediately apparent, such as the fact that what is important in a network of conversation, actually in any conversation, is not how much you talk to other people, but how central you are in the debate. How often do you take turns, and how often do you talk about other people, and how many other people you talk, right? And this characteristic of being in the middle of things, talking a lot about a lot of people without taking a lot of time, right? You can just do it in small bits and pieces. It's called centrality. Now, centrality could be of two kinds. There's the rougher measure of centrality, which is an approximation of sheer volume of communication, but we're not interested in that, right? How many partners conversation are, how many conversations you have. I'm more interested in, how, central you're in the conversation by being in the middle of the other conversations. I'm interested in what is called between centrality. And if you remember Anne, remember Anne was a high between centrality individual. She connected two cliques, right? And I'm giving you here an example, a theoretical example, that it's even more telling than that. So we have nodes 1, 2, 3, 4, right? 1, 2, 3, 4. Now, in this space, we have some nodes that have very high level of raw simple centrality, so 3 or 2, right? Because they have 1, 2, 3, 4 connections, 1, 2, 3, 4, right? And same here. However, this node here, number 1, is probably the most important in the network because it connects this part of the network to this part of the network, the left, the right. Without 1, 2 would not know, 2 or 4 in this clique exist, right? It's the linchpin, if you want, of the conversation. Now, at the same time, in each network, 3 is very important. 3 of each network, right? Which is not to say that having a high simple centrality is not important, but sometimes being a high between a centrality individual is just as important. All right, so this is how you can use network analysis in the simplest imaginable way, right? To tease out some revelatory features about the people. So you connect everybody to everybody based on how much they communicate, or based on if they communicate or to each other or about each other in the presence of each other. And then this network map can be used to figure out who is the really the apparent central and the subtle central individual. Now, I'd like to map onto this idea that some people are more important by what they say, and while some people are more important by, how much they say to whom, right? By adding this concept of practice capital. So I would like you to think about all these interactions as not just idle talk or talking about, but talking together, right? So when I say something about something in a conversation with other people, we are both co-talking about the same thing. In a way, and especially in political debates, what we're doing, we are building a conversation about that topic. We're trying to hash out unimportant issues, especially in policy debates. We talk not just for the sake of talking, we talk to convince, to make a point, to win points, and so on and so forth. So what we're doing together when we work together, sure, we engage in social interaction, but more important, we create the type of practice, right? Communicative practice, right? And this communicative practice, right, being built out of interactions, defines the individuals within this space of practice in a specific way. They are the ones that talk more, the ones that talk more consequentially, right? So, practice has roles and can be valued according to the location in the network that you possess, right? So Practice capital is your number and intensity of connections with other people in a specific type of interaction or practice, which in this case is conversation. And by the way, I consider political talk as a type of practice. There's nothing more practical, or should be nothing more practical than political talk, so to speak, right? And in this space, in these political spaces, I tend to think that people who have high betweenness centrality, who connect cliques, have a very high level of practice capital. Yeah, they're the ones who bridge differences or strike deals or bring things together, right? And if that is so, if we map social conversations in networks, we have the ability to reveal the unseen power brokers or bridge makers. Right? And by doing so, we learn more about, who moves the conversation. But then later on, as I will explain, you can use this to create cues and selection criteria for browsing the videos. And this can lead to new types of data journalism. All right. Okay, let me give you an example. It's an old example because the topic was studied many years ago. I mean, the pilot project was conducted many years ago, but things are just about the same today as they will be tomorrow and forever. So we looked, it was a team, myself and a couple of students, we looked at a policy debate about budget deficit reductions. It was a hearing, a congressional hearing about reducing the budget deficit. It was a hearing conducted in 2011. 17 speakers participated in this debate. There were about 280 minutes of conversation. There were about 115 turns of speech, right? And in this conversation, it wasn't just that they invited experts, but the Congress people talked to each other, right? And senators, they talked to each other, or referred to each other, mentioned each other by name. In case you're curious to take a look, you can click on that link and I hope you'll find the video there, right? So we took, these 280 minutes, 100 turns of speech by about 20 people, right? And we connected each speaker to each other on the basis of, when they actually, in this case, we use temporal sequencing, who spoke about after whom. And as people spoke closer together, then we created stronger links. And if they, spoke a greater distance, we created less links, because this conversation wasn't that involved in terms of me or you, but it was involved in terms of I speak after you and I kind of pick up the conversation here, I say something, and people will take, the conversation from one to another and so on and so forth, right? Now, we used my data mining technology that we used in Wikipedia too. So basically this idea of looking at who talked after whom is based on a script that we created. And, it's a JavaScript of some sort. I'm not going to bore you with this. But in the end, what we did, by looking at who spoke to whom, we got these names: Baucus, Becerra, Bowles, Kemp, Clyburn, Domenici, and all that, right? And we created this network. Now, if you look at this network, at first sight, it's like, oh man, there's a lot of stuff there. Using a network analytic tool that looks at the nodes as they cluster in space. If people talk more to each or closer to each other, then they are stronger connected. We had two groups. We had group one and group two. Group one greater and group two smaller. And then we had stronger relationships based on how much closer they were, marked in solid lines, and then dotted lines showed who spoke less intensely. But this is not the important part. What the important part was this. So we looked at the numbers, and we looked at the number of connections and the number of words people uttered. So we look at how many times somebody intervened in the conversation between everybody else, right? And how many words did they say? And actually, these two numbers did not map. They did not map onto each other. We had Clyburn, for example, who is a power broker, a typical power broker, if you remember him. I think he's just deceased, if I'm not mistaken, right? Who spoke very little. He only spoke 6 minutes, but he take a lot of turns. It's 100 here, but that's the level of centrality, right? So, he had one of the highest levels of centrality. He was more in the conversation than everybody else. He interjected himself in the conversation more often than others. Then Elmendorf, right? Elmendorf, spoke the most, but comparatively speaking, had the lowest level of between the centrality, the blue bar. So we basically can tell by the numbers. Now, sure, there's always a level of analysis where you look at what the person said and how they said it and all that. Maybe Clyburn was the chairman of the session, and obviously he spoke more, but less, right? But that tells you something too, right? This is a signature of power. The people who have the gavel don't need to talk more. They just need to bang that gavel more, right? So, you get a certain picture of the conversation, and then you can go on with it, right? Right. Now, in my view, you can do a lot more with this type of information than just find out who are the power brokers and who spoke more and who spoke less. And again, let's just going back to this. Although this picture looks very, very, very intimidating because there's a lot of stuff going on, you can always boil this down to numbers that are a lot more intuitive, where you count all these lines and you get to something like this, which is much more intuitive. And by the way, this is my first advice to anybody who wants to venture network analysis. Don't get stuck, or don't stop at producing the networks. The networks always look interesting because they're just interesting, but they don't talk by themselves. You need to dig deeper and look at how the connections characterize each individual. By the end of the day, the network is useful not for what it tells you about the general picture, but what it tells you about each individual and their position in the network. What does it tell you about the topology of the network? There are other metrics that you can use for networks that are not individual specific, such as the density of the network, the diameter of the network, and all that kind of stuff. But one very important thing that anybody and everybody should do and should understand about network analysis is that you need to look at how the network characterizes people, right? Now, after you characterize the people and after you put people in their boxes, then you can use that. And I proposed this to Robert a while back, and this is something that we can still do, and we can do it in a more refined way than what I proposed. You can use this to basically sort the individuals. So, this is a mock-up that I created. I don't know if the interface still looks the same, but when you go to the timeline and you get, the people speaking, you can sort it. Right now, I think you can sort it by name or something. But I said, how about we calculate in the background the level of centrality of somebody in a conversation, and we show that person, at the top if they were more central in terms of betweenness. We can also, list people by their level of verbosity, which is this measure of how many minutes did they occupy of the whole entire conversation, or what I call here the level of persistence. Who had more turns of speech, regardless of how much they talk in the conversation, which might or might not be the same thing as centrality. And you can also provide some numbers here and all that. Also, you can have the network, and when you look at the network, you can click on one of the nodes, and then the list is reordered and you see the individual. So this was one proposal of how we could make better use of the C-SPAN archives recordings, right? And how can we mine them on the fly, and how useful this could be. Now, this led to one little project that Robert and I explored over the past year or so. We tried to open up the back end of the C-SPAN archive so that people can pull the raw data, which with the appropriate tools can lead to this type of networks. That's a work in progress. I don't know if you're intrigued enough about that. Please let Robert know. Obviously, I I could also join the conversation and we can see what else can be done, right? Now, as a parting thought, in terms of looking forward, again, I remain of the opinion that the C-SPAN video corpus is a tremendous boon for research. It's a ready-made corpus for network analysis. It can tell us a lot about who said the most and with the most meaning, with the most effect. There are multiple ways in which you can explore this. Intellectually speaking, and I invite you all to think about this, but what's really important is that the C-SPAN archives can be used in this way. And to that end, and again, Robert and I talked about this, the information can be served and should be served as a service that could allow not only the site, the C-SPAN site, to create visualizations, but also third-party sites, which can help you do whatever you want. And maybe, hopefully, you'll also get interested in Practice Capital, and you'll map Practice Capital as well. And with that, I stop, and I thank you very much for your attention. I hope I wasn't too how should I put it, concise, and in case I was or something wasn't clear enough, I'm more than happy to take questions, explain, show you some spreadsheets, where the data comes from and all that. And I'll stop the sharing for now, and I'll turn it back to you, Robert.
Okay, thank you very much. Very useful, very insightful kind of different look at the video library than just video. Tell me, I'll ask the first question, and where does importance, role, and impact, how do you get to those three things that you talked at the beginning?
Yeah. Well, first of all, importance is in the eye of the beholder. So for me, importance is defined in terms of this social practice capital, and social practice capital is derived from your ability to be in the middle of multiple conversations. So in a way, between centrality is your importance, right?
Okay.
Yeah, that's my simple answer to that. Now, in terms of impact, and this is unmeasured yet, but we can think about, the output that these individuals put out, right? And then look at the themes and at the content of what they say, right? And then try to understand that, and maybe measure that or connect that with the policy outcomes and see if that has a measurable impact, right? So this is yet to be measured, but what I'm trying to say, there is a map, there's a road, right? There's a roadmap from the network to understanding how these conversations merit in the real life.
Mm-hmm. Connie, do you have any questions yet?
We do not.
Okay, so Sorin, you mentioned this at the very end, but your data set, just describe what your data set looked like that was the input.
Let me show it to you really quick here. So we took the 280 minutes, right? And we looked at each individual. We parsed each turn of speech, right? And as people spoke one after another, the ones who spoke closer to each other got a link, right? And as people spoke farther and farther away from each other, the link became weaker until it became nothing, right? So if you spoke at the beginning of the hearings and I spoke at the very end, there was no link between us, right? If I spoke at the beginning and you spoke in the middle, we had a very weak link. If you spoke right after me, we had the strongest link, right? And we used a mathematical formula, which is similar to the formula of gravity, which basically says the farther away, the weaker, and actually by the square of the distance. Now, let me show you what the data set really looks like, because it's there's a visual illustration of the data set. Okay.
I'm really sorry to interrupt, but I think the chatting box is currently disabled for the participant. Would you please check it?
The what?
The chatting box is currently disabled.
Oh, the chat box.
Oh, okay.
Connie, that would be your precinct or Andrea's.
Okay. So,
Yeah, so, but while she's doing that, I hope you can see my screen now, right?
yes,
Well,
yes.
so this is what it looks like. So, we took Camp, Bracerac Hill, and we listed them. I don't have the list of, blow by blow. That was done on the fly by the program. We did not save the list of turns, but we did save the list of connections after we analyzed the data, right? So Camp was connected to Bracerac Hill, Upton, and Murray, and Van Hollen to Upton, and Toomey to Upton, and Hensarling to Camp, and so on and so forth. And this edge value is a calculated value that basically measures, these distances. Now, obviously, if somebody spoke after me several times, we add up every edge, So if you spoke right after me, and 5 spots after me, and 6 spots after me, you get a higher value for your connection to me, although it's not 3 times higher than somebody who just spoke after me, because the 5th and the 6th is a weaker connection. Right, so then we use these values here to create that map that I showed you. Now, there's a piece of software that I would need to dig it out. Unfortunately, my students graduated many, many years ago, and it was written in Java, but if anybody is interested, we can work together. I have actually some very talented students that could recreate this code in what's called nowadays fast prototyping Jupyter notebooks. This is something that we like better. And in Jupyter notebooks, you can do a lot of things, and the code is more transferable.
We have a question for you, Sorin.
Yes.
Could you speak a bit about your process for data mining in the C-SPAN archives? What pitfalls should we consider? We try to gather network or other relational video or textual data from the C-SPAN archives.
Yeah, well, just any highly specialized databases, right? C-SPAN archive is not a corpus of all political conversation. It's first and foremost a corpus of highly structured political conversations, right? So you have to keep that in mind. Also, another thing that needs to be kept in mind is that many of the hearings or other events are highly scripted, right? So they're not as freewheeling as you would imagine. That's why it requires a little bit of creativity and thinking about what people do, right? Actually, that's why I did not use the more intuitive manner of connecting people in a conversation, where you look at if they talk to each other or if they address each other. That would be much more difficult in a hearing, right? But at the same time, I want to highlight the great advantage of the C-SPAN archive, which is that the C-SPAN archive, it is a record, a truthful record of history, probably better record of history than the Federal Register, which is stuffed with everything and anything, right? Actually, if you go to the Federal Register, which is stored in the digital format and all that, and if you want to see who said what to whom, you'll be surprised. There's stuff that people claim they said they never said, right? Or there are attachments to their speeches that have nothing to do with what they said on the floor, right? So there's the disadvantage that, it's very constrained, hyper specialized space, but at the same time, it is what it is.
So Sorin, I had a question about how you deal with the fact that not all of those people in that grid were members of Congress. There were several of them who were actually the witnesses at the hearing. So the dynamic between the speaker, who is the person who is testifying, would be much different than a member of Congress who couldn't just jump in anytime they want to. How do you?
There's this methodology called network partition, right? Or block modeling, where you can assign to individuals certain characteristics, and then on the basis of those characteristics, then you can push them in a certain corner of the network and treat them separately. That's very doable, very easy to do, and it's just an issue of coding. I treated everybody here the same because I wanted to show, how it works at the basic level. But when it comes to a more sophisticated analysis, network analysis as a field, as a discipline, has multiple ways to handle these refinements.
Mm-hmm. Mm-hmm. Would you be able to handle another dimension? Say you had the dimension of proximity in speaking, but let's say you use, we heard from Rod Hart, and what do you use, some like emotion
Yeah.
detection?
Yeah, definitely. I mean, we can, yeah, if for each individual, we measure, if they were angry versus happy, right?
Mm-hmm.
So we can connect, you can combine this with time, probably that would be better, right? So you have windows of time, right? Window 1, 2, 3, 4, 5, right? So in each window, then you have 4, 5, 6 people talking to each other, right? And some are happy, all those who were happy during this window get a link between themselves, right? And all that are angry, they get a link. But in this next window, people will be happy and angry in a different composition. So now you have connections between people who in the previous window were not connected. And as you move through these windows, then you have a very complex picture that shows who was connected with whom, right? And who was, on average, the most connected to all those that were happy or angry or anything like that. This would be very similar to connecting people on the basis of keywords, right?
Yes.
Right? Yeah, so it'd be the same thing. It's just that it's a different way of thinking about it. These networks are called networks of affiliation, right? If you want to think about it, it's like trying to map, the structure of a network of a city or of a town elite network on the basis of the organizations they're a member of, right? So you might have somebody who's a member of many organizations, right? And has very high centrality. And then you might have somebody who's only a member of 2 organizations, but all the other people are kind of connecting between each other. So, this person would really matter.
Sorin, could you go ahead and stop sharing your screen?
Oh, sure.
That'd be great. Thanks.
Yeah.
Mm-hmm. Other questions anybody has are either Sorin is talking about committees. There are lots of different types of videos, debates, floor debates, or questions that you might like to try to answer.
Here's another question, Robert.
Mhm.
Sorin, practically, how can you use your approach with greater metadata on the participants? For example, have you pulled in other data on speakers into your network analysis, i.e. data beyond C-SPAN, such as geographical data, ideological data, polling data on their constituents, et cetera?
Yeah, no, again, this is a proof of concept. This is a pilot study. I did not go that far. It's an older study, but again, if you think about this methodology this way, you'll see that it's infinitely expandable. So you have nodes. These are individuals, right? And the individuals are connected to each other on the basis of what they talk, right? Of what they talk, or on the basis of how they interact, right? But then each node can be assigned characteristics, right? Such as gender, such as speakers versus witnesses, such as state, such as age, such as race, right? And these characteristics can be used either to pull the network apart and create sub-networks, right? Or to engage in a type of analysis, which is quite interesting, which is called network regression, where it's like our typical regression is say, are people of a certain gender more or less likely to talk, consider everything else, including what their level of network centrality, right? And yeah, there's a way to do that. So network analysis is a expandable methodology that could work very successfully in presence of richer data. The question is, how do you add the data to your to your, I mean, the question is, do you have the data and do you have the time to add the data? Just really quick here to illustrate this with my file here. Sorry, here, share. I mean, it'd be very, very simple for me to create another, let me see here, do I have it here? Let's just say, you know, it'd be very, very simple for me to create another column here where I list every single individual, and then I have a list of columns, right, that identifies that individual's, again, race, years in Congress and all that, and then connect them back to this file, right, each time the person appears. I'm going to show it in the network analysis.
Connie, can you look at that?
Yeah, let me disconnect again.
Connie, I think you're muted.
My apologies. Emily, who had asked that last question, asked if you could share links to any of your write-ups, your working papers or publications on this method so that we can dig deeper.
Yeah.
Yes.
Sure.
If you go to, let's say we'll send a link here. I think it's very easier to do that. Sorin's paper is in the first volume of the C-SPAN book.
Yeah. And I have another couple of papers that apply the methodology in different ways to different topics that can provide an idea of how to work with this. One thing that I would recommend to anybody who is intrigued in network analysis is to take a look at Node Excel. This is a piece of software, but it's a very powerful piece of software that can provide you a hands-on, working introduction to network analysis in a very fun way by using Twitter. And if you think about it, you know, Twitter is a similar space, right? It's sure, it's not scripted, it's not recorded, it's not a hearing, right? But it is a practice space, is a conversation space where people either speak to each other or speak the same things or speak, you know, taking turns, right? And Node Excel actually take strings of Twitter interactions and turns them into networks in a very similar manner to what you saw here.
Mm-hmm.
And there's a book that comes with Node Excel that, you know, it's actually half of it is an introduction to network analysis.
So Sorin, you use a lot of Purdue undergraduate students who program and graduate students, but what software, that's one you talked about.
Yeah, Node Excel is
where
ready.
should they start?
Yeah, Node Excel is
explore what they could do with some simple data.
Yeah, definitely. So Node Excel is a ready-made piece of software that calculates network centrality and other types of metrics and displays the network in a very clear and interesting way and partitions it in groups and all that the way you showed it. Now, the one thing that Node Excel doesn't do at this point is to go to the conversations and parse them out into turns and convert the string of conversations into turns. But you can yourselves can do that if you don't have the programming skills needed manually. You know, if it's not something very onerous, you can take the script of a conversation, define where somebody's turn starts, and then define how connection between that person and other people should be counted. Do they mention the same word? do they talk after each other, whatever. And then create the list like the one I showed you, where you have each individual listed as many times as you consider to have a connection to someone else. And then for the value of the connection each time they interact, it could be the number of words they used in common or any other type of metric, if that's what you want. Now, we ourselves, again, we used back in the day, this JavaScript program, which was a little bit clunky. I would like to move, if I were to go in this direction, to the so-called Jupyter Python environment. We have any number of talented kids here at Purdue that can help you do that. If you're at Purdue, all you have to do is to sign up for the DURI internship program, the Discovery Undergraduate Research Internship Program, spell out what you need, and you'll be matched with people in no time. As the Associate Dean for Graduate Education and Research, I keep an eye on these opportunities. If somebody, on other opportunities, if anybody wants to engage in this type of research, let me know, and I'll try to connect you with the right people. Right students or right colleagues. There are several colleagues in the School of Communication who are experts in network analysis, much more expert than I am. And then we have colleagues in computer science who are statistical experts, which is something that operates at a very different level. And yeah, we have a lot of installed capacity at Purdue if you're intrigued in network analysis and you have not dabbled in it.
So here's a question. Is there a way, or did you, to weigh interactions, such as adding more weight to interactions that involve substantive topics as opposed to general procedural interactions?
Yeah. No, definitely there's a way. Actually, weighing is built into the system. Now, for me, weighing is how far or close you talk to somebody in a given conversation. But if you go back to my example here, you see that we have this edge value here, and the edge value is, varies from pair to pair. And this is based on at what distance did each interaction take place, right? Let me see here, data, filter. Okay, and if we do this, if we do ascending, yeah, actually Camp and Bersera where the tightest connect and then the values go down. Yes, this is based on a logical network analysis, and that the network that you build will be called a weighted network.
I want to mention also the link that Dr. Browning mentioned earlier to Sorin's book in the C-SPAN archives that has his paper on this. It is docs, docs.lib.purdue.edu/CCSE.
And I apologize for the clarinet. Somebody in the neighborhood is playing the clarinet.
Is it a recorder or a clarinet?
It's a clarinet. Does it bother you? Is it noisy? I'm sorry. The joys.
We have time for more questions if anybody has any.
I do want to say that Sorin is a great resource. He's a great idea person, but he's also in a position, he's got a lot of expertise in this area of big data, but he's also in a position to make connections.
Yes.
So if you've got an idea, you want to know how you can find somebody else interested in it or find a resource or whatever, don't hesitate to ask him. He's been very good that way. So anyone else? Well, we can end a little early. We appreciate everybody participating, and we'll have another session that'll be more on facial movements and how you can measure facial movements to get emotions and things of that sort in debates, which is a very interesting nonverbal way that people are doing research. So again, let's give Sorin a round of applause, and Connie and Andrea for putting this together.
Sorin, thank you so much.
Thank you. Thank you. Thank you all.